In this example, we're given a graph of a function y equals f of x. So this is a graph consisting of 3 line segments. And just so you can be clear on what the graph looks like, since you're maybe working from what I've drawn here on the whiteboard, let me label a few of these points. So it's got an end point at -3, 0 here. And then it goes up to a point at -2, 2. Right, this corner right here is located at -2, 2. And then it goes straight across to this point at 1, 2. And then there's a line segment extending down and to the right, ending at the point 5, -2 here. Right, so just to be clear on our basic graph. The idea with problems like this are to force you to use transformations to sketch the graph of a given equation. So this isn't something that you can type into a graphing calculator to get the answer. Okay, so this is our graph of y equals f of x. We want to use it to sketch the graph of this equation. So the first thing we need to do is determine what transformations need to be applied to transform the graph of just plain old f of x to the graph of y equals negative f of x plus 2. So a couple of things here. The plus 2 is inside of the function. So whatever happens inside of the function corresponds to a horizontal change in the graph. If it's x plus a number, that corresponds to a horizontal shift. The horizontal shifts do kind of the opposite of what you expect if you just look at the value. Plus 2 will actually shift the graph left 2 units. So one transformation we need to apply is to shift the points left 2 units. Now you also have a negative in front of the function. So this is a -1 times the function, as opposed to like an f of x minus 1, which would correspond to a shift down 1. When it's a -1 being multiplied by the function, that corresponds to a reflection. And since that negative is outside of the function, it's going to reflect vertically. Anything that's applied outside of the function corresponds to a vertical change in the graph. So this is going to reflect vertically, which is across the x-axis. If you flip it vertically, reflect across the x-axis. Okay, so we need to perform those two transformations. The rule of thumb is horizontal transformations always come first. So we should first shift the points left 2 units and then reflect them across the x-axis. So that's our plan. So now we want to go ahead and apply it. So go point by point. I'm going to transform each of these corner points, because then we can connect the dots and draw the new graph. So starting with this point at -3, 0, if I first shift it left 2 units, so it's going to go left 2 this way, and then reflect it across the x-axis, well, when I shift this point left 2, it lies right on top of the x-axis, so it won't reflect anywhere. When it's just right on top of the x-axis, you reflect over the x-axis, it's not going to go anywhere. This point will actually reflect somewhere. Okay, so we take this point at -2, 2. Shift it left 2 units. So when you shift left 2, now it's at -4, 2. And then reflect over the x-axis. So flip it from +2 down to -2. So it should land at coordinates -4, -2. Because it shifted left 2, so that's going to subtract 2 from your x coordinate, and then flip the sign on your y coordinate. So we get 4, -2. And I'm going to go ahead and connect those dots. Ooh, there's our first line segment transformed. So overall, this line segment shifted, or use this hand to, shifted left 2 and then flipped over the x-axis to get this segment here. Now I'm going to take this corner. Shift left 2 units. So when I shift left 2, it's going to move over to -1 for its x value, and then reflect it over the x-axis. So it's going to flip from y equals +2 to y equals -2. And so the transformed coordinates for this point 1, 2, it lands at -1, -2. And then I went ahead and connected those dots for this line segment. Shifted left 2, reflected over the x-axis. Last point. So take this point, shift it left 2, so it's going to land right here, and then flip that point over the x-axis. So it's going to flip from where y is -2 to up here where y is +2. So it's going to land at 3, +2, because it went left 2, it went from 5 to 3, and then from -2 to +2. And then connect those line segments, and I get that line there. And so this graph in green is the graph of this equation here. Notice that overall, when you take a step back, it should look like we took this graph in black, shifted it left 2, and then flipped it over the x-axis. And that is overall what looks like happened here.